Good morning, good Thursday morning, April 30th to Kentucky AP Environmental Science students and teachers. This is the last of our AP Environmental Science content review sessions to prepare you for the May 18th exam, or to help you prepare. We hope you're doing stuff on your own and this fascinating material. We are fortunate again to have Debbie Wheeler presenting for us. Debbie is an AP Environmental Science reader and teaches at the Sierra School out there in Lexington. I guess out there for me. I'm here in Louisville, and I know you are scattered around the state. I'm, to remind you, Lou Acampora, but you don't need to know that, and I'm ably assisted by my colleagues. We'll have several students on this, so please, just a reminder to turn off your microphones and video, but do use a chat box. Debbie will be asking some questions, and we'd like you to participate as much as you feel comfortable, even more so. This session and all others are archived at kyap2020.com, along with some support material. So as you prepare, and if you want to review stuff, feel free to go there. So once again, this is Debbie Wheeler. She knows her stuff, so give her attention. And I will turn the podium over to her.
Good morning, everybody. We're going to talk about energy and non-renewable energy today, and I would like to just go through a few basics, and then we'll get to a game I'm hoping to play. We'll see how that works on Zoom. All right, my first question for you is, what is the difference between non-renewable and renewable energy? And please answer on chat if you would. What is the difference between renewable and non-renewable energy? Non-renewable energy will run out, but renewable won't. Absolutely. Time plays a huge factor in that as well. So if we look specifically at this diagram of how non-renewable energy is formed, it takes millions of years to form our non-renewables. So, swampy areas millions of years ago had an accumulation of detritus. And over time, that detritus, that material that had been photosynthesizing is buried, and it eventually, time compresses a lot of water out of that, concentrates that energy into fossil fuels, which we then extract and burn for energy. Renewable resources can be replenished if we're using them at a rate that allows them to do so. And although the fossil fuels are still forming, we know that it's going to take millions of years, and we're using them at a much faster rate than that. Okay, so today we're going to play a trivia game. I'm not going to keep score. It's, I think, maybe too much for me to keep score and run the game. So you've got 5 categories: general, fossil fuels, nuclear power, miscellaneous, and renewables. And if you would pick a category, anyone that's here with us can do that, and a point system. Renewable for 500.
Ooh.
Okay, Ty.
Going for the
start
gusto.
off with a bang. Most of your personal energy usage comes from these 3 areas. So if you're thinking about reducing your impact, you would think about these 3 general areas.
Now, they do not need to answer in the form of a question, correct, Ms. Wheeler?
No, although a lot of this game is set up like Jeopardy style questions, you don't have to answer in the form of a question. We do want to get all 3 areas. So feel free to throw out one, and we'll see if we can together accumulate all 3. Cars, okay. So fossil fuels are going to power these, potentially. Food, good. Looking for one more way. And you might think about how you, electricity. So paying for, what is your electricity going to fuel in your home? Appliances, heat, yes, nice. So transportation, agriculture, and heating and cooling are the main ways we use energy in our houses. So we got pretty much all of those in that little bit. Okay, let's return to the board. What other area would you like to explore? General, fossil fuels, nuclear power, miscellaneous, or renewables? Miscellaneous for 500. I can see
People
you're
are
all
going for the high point values here.
All right, here's a little bit of math. If the annual consumption of petroleum in the United States is 23 barrels per capita, then what is the annual consumption of petroleum total? So you need to know a vocabulary word like per capita. Can you first tell me what per capita means? That's a good definition for per capita. Not necessarily per capital, although there's similar derivation. Yeah, per person. So per capita would be like head. That's where the word capital comes from, like the head of your state. So per person, per capita. So we need to know how many people are in the United States in order to do the math in this problem. How many people are in the United States? Good guess, 350 million. Let's keep the number simple and just call it 300 million. So yeah, you guys are definitely in the right ballpark on total numbers. See 328, 329, 350, but let's assume there are 300 million people. So how are you gonna do this math? Yep, 300 times 23. Anybody got a calculator handy? Now that we do need to get to use calculators in AP Environmental.
Well, I know 3 times 23 is 69, so that might help.
Yes. And that's the great way to do it too. Yep, 6,900 million or 6.9 billion. Excellent. Okay. What other category would you like? And how many points would you like to go for? Nuclear power, fossil fuels, general, nuclear for 300. All right. A sample, another math problem. A sample of radioactive material has a half-life of 20 years. It has an activity of 2 curies. How many years does it take for the material to have an activity level of 0.25 curies? So this is maybe a little bit simpler than you'd think, and I've got a quick way to show you how to do it. 60 years, nice. That is absolutely correct. A quick way to do this, if the half-life is 20 years, so you're starting out with 100%, after 20 years, you'll have 50%. So when it started out with 2 curies, now you've got 1. After another 20 years, 25% is left, that would be 0.5. And after that third half-life, you've got 0.25 curies. And so that's a good, quick, and easy way to come up with that answer. Nice, okay. Category and points, please. General, fossil fuels, nuclear power. General for 500, okay. This has been the effect on oil prices because of the COVID-19 pandemic. I had to put this in here so we could keep current. They have dropped. They have dropped very significantly. So check out this graph. Let me see if I can make it a little bit bigger. So if you follow the graph, you know, we start out, I think this is maybe starting at year 2000, at about $40 per barrel of oil. And then we saw prices get way high. And this was when gas was like $4 a gallon. Then we hit the 2008 recession. We see a huge drop in demand for oil. It popped back up, never really reached that high that we had seen before. And then we saw prices get low here. This is representing US increasing oil production due to hydraulic fracturing. So we're hydraulic fracturing for natural gas, but also for oil. And here's where we are today, $15 a barrel. At one point last week, trading got into the negatives because petroleum is so not in demand right now. And there's also been just a glut on the market because of a price war between Saudi Arabia and Russia. So steep decline. That's my COVID-19 reference. All right, what else would you like? General, fossil fuels, nuclear power, miscellaneous, or renewables? Miscellaneous for 100. An industry uses natural gas for manufacturing and uses the waste heat to produce electricity. So I'm looking for what that is called. And that's basically one word. An industry uses natural gas for manufacturing and uses nice cogeneration. Excellent, Colin. Yeah. So it's called cogeneration, sometimes known as CHP, combined heat and power. So we know that if we're just generating electricity, it's only about 40% efficient. Let me make this a little bit bigger. But if we take that heat, which would generally be just a loss, you know, of waste heat, you know, heading out our cooling tower, if we use that to heat a building or heat water, then we can increase our overall efficiency pretty significantly. Okay, well done. All right, what's next? Category and points. What are you interested in? Fossil fuels for, I assume that's probably 500. Yep. Okay. Fossil fuels for 500. We'll start there. Ooh, that was getting a little bit, I think that got a little bit ahead of ourselves. I'm not sure I can go back. I'm going to do fossil fuels for 400. This is the order of the cleanest burning to the dirtiest fossil fuels. Cleanest burning to the dirtiest. So I'm sure we're all typing in an order right now. Okay, natural gas is number one for cleanest burning. Absolutely right. Followed by oil, followed by coal. Excellent. Which one is the most abundant? Which one is the most abundant? And you can, you know, think about coal is definitely the most abundant. And then natural gas is probably the second most abundant. It's not coal. We probably have 250 years worth of coal. Petroleum, well, 50 years is what they've been telling us for a while. And now that we're not using very much recently, it's probably lasting even a little bit longer than that. Okay, I'll come back to that last question on 400, but I have to exit the game to do that. So you guys remind me, depending on time, if I forget, because I do want to talk about that important topic on number 400. But what would you like for now? We could hit our only 500 we haven't quite done yet, if you'd like to go for it, or we can get some, we can work our way up there. Yeah, all right, go for it. Nuclear for 500. Name the most severe nuclear accident and the most recent. So those are going to be two different ones. The most severe nuclear accident and the most recent. And we'll talk a little bit about them. Okay, Chernobyl is the most severe. What about the most recent? Yes, it's actually Fukushima. Excellent. So Chernobyl, by the way, there's an excellent movie on HBO about what happened in Chernobyl. It's really, I mean, it's well acted. So it's not just great information, but it is well acted. So that happened in April 1986. It was definitely the most severe as far as the most radioactivity released at once. The Fukushima Daiichi plant accident that happened in March 2011 has been maybe, it's definitely the most recent. It's probably been the hardest to contain. Do you know what caused Chernobyl? The name of the movie is Chernobyl, and it's on HBO. It's excellent. Do you know the name, the reason why Chernobyl occurred? I'm sure you guys are feverishly typing. It was a leak. Yes-ish. Nobody listened to one scientist. So Chernobyl and really all accidents up until Fukushima occurred. Yep, there was an overheat. Occurred because people had interrupted the normal operation of the nuclear power plant. Chernobyl had actually was operating at very low power, and it caused some instability that eventually led to a major explosion and a massive release of radioactivity. It blew the containment chamber apart. And we've just recently, in 2019, put a sarcophagus over the top of it to try and reduce radiation release. Fukushima was not a human error sort of accident. What happened at Fukushima? There was a tsunami. Yep. And that was ultimately what caused the partial meltdown. Yep, earthquake and then a tsunami. So there was an earthquake that took all of the electricity offline at the Fukushima Daiichi plant, but that's okay because they had backup generators going and those immediately kicked in. Because in nuclear power plants, it's really important that you keep the coolant pumping through the reactor. You can't just turn a nuclear power plant or a coal-fired power plant on or off. They need a while to gear up and they need a while to cool down. And after the generators started, continuing that coolant pump, there was a tsunami that, flooded the generators. And that's really the reason for the meltdown. There was no way to keep that coolant water continuing to run. So do you know what nuclear power plants and coal-fired power plants are called? Power plants that are going all the time? They have a particular name. Hopefully we're typing, thinking about what that name could be, what we call those type of plants. 5, 4, 3, 2, 1, constant. They're called baseload power plants. So we can add some other power plants like hydroelectric on when we have increases in demand. But in order to make it so when you plug something into that light socket, you've got power immediately, we have to have baseload plants that are providing power all the time. So those are the coal-fired power plants and nuclear power plants are called baseload plants. All right, let's pick another question. We have a few available in every category: general, fossil fuels, nuclear, miscellaneous, or renewables. Let's try general for 100. These are non-renewable energy sources. So this feels really easy after some of the complex ones you all chose. So what are the non-renewable energy sources? Coal? Yes. Oil or petroleum? Yep. Nuclear, fossil fuels, natural gas, we got them all. All right, so fossil fuels, coal, natural gas, petroleum, and we do have to include nuclear power in there. That's the one that we sometimes forget. Remember that fossil fuels does include petroleum as well as oil shale and oil sands, because that's just where we've got oil that's trapped in either shale rock or it's trapped in sands. And that's going to be a common resource you find in Canada. All right. Renewable for 300. Burning hydrogen releases heat and this product. Burning hydrogen releases heat and this product. Water, nice. Yeah, so this is related to renewables because we're talking about a hydrogen fuel cell. And the way hydrogen fuel cells work is we have to have free hydrogen that comes in, reacts with oxygen. It releases heat and it releases water. So a hydrogen fuel cell vehicle, the only thing coming out of the tailpipe is going to be heat and water vapor. So that's kind of cool. Is free hydrogen available in the world? Is there a reservoir of, no, there's not free hydrogen available. So how can we make hydrogen fuel cells truly renewable? What do we need to use to do electrolysis and feed us a supply of hydrogen we can use? Algae? I'm not sure how that would necessarily work. We would definitely start with water, but we're going to have to do electrolysis to split hydrogen and oxygen and then trap that hydrogen. Yep, photovoltaics, absolutely. So we can use non-renewables to do this process, but it probably doesn't make a whole lot of sense if we want to make it renewable. All right, I need another category and another point value. What would you all like to learn about next? Talk about photovoltaics? Sure. So solar power is photovoltaics, and that solar panels is probably the name that you've most likely heard about. How does solar panels work? I'm not sure if that's where you were going with that, Ty. So solar panels are made of usually a silicon strip that's going to allow the energy from sunlight to bounce an electron out of that material. and then it's going to capture those electrons in the stream of electrons, which is electricity. So yeah, photovoltaics or solar panels. Okay, next category, miscellaneous for 400. Absolutely. What's the difference between passive solar and active solar? That was a nice segue, talking about photovoltaics. What's the difference between passive solar and active solar? And feel free to just identify one, and then we can let somebody else identify the other. Active solar is solar panels. Active solar photovoltaic. Nice. Active solar creates electricity from solar energy. That is absolutely true. So what is passive? Does it require technology? To a degree, absolutely. Yes, achieved through the design of the building. So let's take a look at that. Here's a diagram of a building showing us passive solar happening. I actually got this from the University of Kentucky's solar website. So if you build a building that's south-facing, then you're going to be able to bring in sun during the winter. The winter sun is lower. That's what you can see going over here. And you're going to build your building with large windows on that south-facing side, and then a roof overhang. And summer sun is higher. And so that roof overhang is going to prevent sun from coming in when we don't want it heating up our building. But in the winter, it's going to allow sun to come in. And then we're going to have some sort of a floor, maybe that's made of tile, that's going to be able to absorb that heat. We're going to have some insulation in here that's going to help us retain it. We might even plant, a deciduous tree out here so that it blocks some of that light in the summer when it's all leafed out. But that's passive solar. And as you guys said, active solar is going to be some sort of technology where we're converting solar energy into another useful form, like photovoltaic panels or solar power. So well done. Okay, what would you like next? We still have some in every category. Renewable for 400. Which country heats over 80% of its buildings with geothermal power? Which country heats over 80% of its buildings with geothermal power? Yep, Iceland. Here's a nice diagram of a geothermal power plant in Iceland. So it's got lots of volcanoes, lots of volcanic activity, and this actually came off of Iceland's power plant site. And if they're able to harness, if there's a water reservoir and they're able to harness some of that heat to generate steam, then they can use that to run their turbine, generator, and generate power.
Come on, I gotta change your diaper.
And then we can put that water back into that reservoir to repeat the process. Why can't other countries do what Iceland is doing? Why can't other countries follow suit and do what Iceland is doing? Yes, I mean, Iceland is uniquely located between the North American plate and the Eurasian plate. And that's, why they have so much volcanic activity. New Zealand also, I don't know that they do as much geothermal power. We're actually hoping to visit, my school's hoping to visit Iceland or New Zealand soon so we can see that, because we did visit Iceland with a small group of students and check out their power plants there. But I don't know that New Zealand has as much. They're definitely renewably thinking kind of country though. All right, what would you like next? General, fossil fuels, nuclear power. Nuclear power for 400. Name at least one power plant component only found in nuclear power plants, and then impress us all and explain its purpose. Name at least one power plant component only found in nuclear power plants, and then go ahead and give us the purpose. So there's lots of options here. Okay, uranium is going to be the fuel they use. Control rods, nice. They're going to keep the system from overheating. Fuel rods, awesome. They're going to have uranium. Control rods are going to absorb excess neutrons. Excellent. Anything else you can think of that might be different between those two power plants? They definitely have some similarities. They're both thermal power plants. Coal and nuclear is what I'm thinking of. No pollution. Okay. Radiation shielding. Awesome. All right. Here's a nice diagram to help us think about that process. So In a nuclear power plant, we have this reactor core. That's where our fuel rods are going to be located. That's where our control rods are going to be located. As I think Colin said, they're going to absorb, the control rods are going to absorb excess neutrons. We can pull those control rods out to speed up a reaction. We can put those control rods in to allow them to absorb some of the neutrons and prevent the fission process from continuing to happen. You can see that this, I like this diagram because it's got the different types of water that might be involved. You can see this is a closed loop system. So if you see a nuclear power plant that's got a cooling tower, you know that steam coming out of there and it's not emitting radioactive material into the air if it's functioning properly. But it's going to heat up this water, create steam, run our turbine, generate our electricity. Okay, so you could have said containment structure, lots of good possible answers in that. You guys got the important ones though. Nice job. All right. What else would you like? We have a few left in each category: general, fossil fuels, nuclear power, miscellaneous, or renewables. General for 300. These types of motors can be found in a hybrid car. These types of motors can be found in a hybrid car. And you can tell by my answer there's more than one. Or my question? What types of motors are in a hybrid? Ooh, have I stumped you? Electric motor? Yes, absolutely. Definitely an electric motor, but it's not the only type. What else is there? Probably not hydroelectric. The hydroelectric plants are going to exclusively produce electricity, but definitely electric. Somebody else, what's the other motor that's in a hybrid? Yes, internal combustion. So if you drive a hybrid car, you still have to go and get gas periodically. You just go a whole lot less. I went and got gas I drive a Prius. I went and got gas a couple of days ago and it cost me $12 to fill up my tank and it was pretty empty. I mean, obviously that's because gas is so low, but it's you know, very inexpensive to fill up my tank, but it does require gasoline. So you can see in this model, we have a traditional internal combustion engine that's going to require gasoline in order to run it. When the hybrid car brakes, it will charge this battery that's in the trunk, and actually a hybrid car is going to get a lot better gas mileage in stop and go traffic when you can charge that battery than on a highway where once you get over 25 miles per hour, you're pretty much relying on, or a good deal of your energy is coming from your internal combustion engine. So hybrid cars are not electric cars, and that's one of the reasons why I included this question in there. They're different, you know. An all electric car, you're going to plug that in and you're going to use whatever primary power source is going to, you know, provide your electricity. And so if you're plugging in Kentucky, you're, you know, recharging your car on coal, unless you have a photovoltaic or a solar panel up there that's doing that. Okay, what else would you like? We have some in every category: general, fossil fuels, nuclear power, miscellaneous, and renewables. General for 400, awesome. This is a non-renewable energy source that doesn't produce carbon dioxide. Non-renewable energy source that doesn't produce carbon dioxide. Andrew will do 300, miscellaneous next. Nuclear, awesome, yeah. And that one feels really easy because we mentioned that. So I saw miscellaneous for 300, I think, earlier in the chat room. List a major disadvantage to wind power and a major disadvantage to hydroelectric power. List a major disadvantage to wind power and a major disadvantage to hydroelectric power. Wind power noise. Colin, can you be specific about birds? Sedimentation. At which power plant? Just be specific. Wind noise, good. Cost could be for both of them, but yes, hydroelectric sediment. Wind, yes, migratory birds, hydroelectric habitat alteration, very good. Yep, dam construction is going to cause a problem with that. Wind kills bats and birds. Hydroelectric does require a suitable site. Wind can be more productive. Good, it's intermittent. It can be more productive in some areas over others. Anything else you want to add before we discuss the answers? How the electricity is stored and transmitted. Interestingly enough, if you want to put in a wind farm, you probably are not going to install batteries, so you'll need to have power lines that go out there, and that's a huge issue with wind. Okay, let's look at some of those possible answers. And we had these, I think. Wind disrupts bird migrations, so it can kill birds. Noise pollution, especially if you're right under it. Visual pollution, it gets complaints for that, even though I think they're pretty beautiful and awesome. Intermittent, that picks up what someone else had said about how the wind isn't blowing all the time, so you're not necessarily going to get power all the time. And that's why this, wind turbine, a bunch of wind turbines are not going to be your baseload plant. You still have, nuclear or coal, unless we can find another resource. You need some other resource that's always available in order to keep that going. So these are plants you can bring online when you need it. Expensive upfront costs we mentioned, just like hydroelectric, they're expensive to build. Hydroelectric, I don't know if anyone said this, disrupts fish migration, so that's huge. We talk about salmon that go from the ocean, swim back up river in order to spawn, and it can really impede that population and cause reduction in salmon numbers because of hydroelectric dams that have been built along the river. Here's one that maybe you hadn't thought of. Decomposition in the dam area can release carbon dioxide and methane. We know methane is 20 times more potent to greenhouse gas than carbon dioxide, so that's pretty significant if we have methane release occurring there. It does, someone mentioned this, it does flood large areas. It's going to displace people and animals that are living there. So those are both important. Okay, I'm not sure that we could really say thermal pollution because those aren't necessarily thermal plants. All right, awesome. Well, we've got all the tough ones. I am going to come back to 400 for fossil fuels. What else would you like? Let's do fossil fuels for 300. I like it. This molecule reacts with water vapor in the air to produce acid rain. What molecule reacts with water vapor in the air to produce acid rain? Sulfur dioxide. Awesome. So sulfur dioxide is going to produce sulfuric acid when it reacts with water vapor in the air. What does the word anthropogenic mean? Because I've got another question for you. Anthropogenic source. What does anthropogenic mean? From humans, human caused. Awesome. So where does sulfur dioxide come from? What's the anthropogenic source? Definitely coming from humans, from burning coal. Yeah, specifically. It can come in a lesser amount from other fuels, but mainly from burning coal. Just for fun, what's another air pollutant that's emitted by coal burning power plants? There's actually a few you should be able to come up with. Mercury is the big one I was thinking of. Yes, that's another big problem. Of course, like all fossil fuels, carbon dioxide might have come to mind first, but yes. Okay, next category, general fossil fuels, nuclear power, miscellaneous, or renewables. NOx does generate acid rain. I see that in the chat room. That's absolutely true. Sulfur dioxide is probably a bigger cause, but nitrogen oxides can as well. Okay, what category and what difficulty and question level would you like? I don't always match up, but I try. General, fossil fuels, nuclear power, miscellaneous. Nuclear for 100. What's the difference between nuclear fission and nuclear fusion? What's the difference between nuclear fission and nuclear fusion? Fusion takes a lot more heat and pressure to make it happen. Okay. Fusion happens in stars. What is fusion? Something is combined. What gets combined? Yes, we're combining atoms. And fission is splitting. Awesome. So nuclear fission is when we're splitting atoms of uranium. So we're taking a uranium-235 atom. It's being hit by a neutron that's splitting it into two smaller atoms. It's also releasing energy, which is why we're doing it to generate power. It's releasing energy in the form of heat. And then it's also releasing 3 other neutrons, which can continue that process. Since we've already talked about the structure of a nuclear power plant, if we add control rods to absorb some excess neutrons, then you can kind of see by this diagram why that's going to slow the reaction down. Okay, and then you all mentioned fusion. You explained that, fusing of atoms, like what's happening in the sun. Helium and hydrogen are fusing, sorry, helium is fusing to produce hydrogen. No, hydrogen atoms are fusing to produce helium. Is that right, Lou? I'm a little tired today. I want to make sure that I'm not making
hydrogen combines to produce helium. Yes.
Yes, and so helium is our product. Something I was going to make. Oh, Colin kind of brought this up. It takes a lot of energy to do that, or a lot of heat and pressure to do that, and it does. We've tried to, because the waste product is helium, it would seem a lot easier to handle than the waste products of nuclear power plants, which we'll get to in just a minute. But it's not, there's not a container that can hold the molecules at that heat. I think it has to be like 3 million degrees in order to heat up that, in order to cause fusion to happen. So it's not really at this point viable to have a fusion reactor that's going to generate heat to produce electricity. Okay, fossil fuels for 200. How does the burning of fossil fuels contribute to a net increase in atmospheric carbon? How does the burning of fossil fuels contribute to a net increase in atmospheric carbon? So make sure we explain enough about that to really show we understand it. How does the burning of fossil fuels contribute to a net increase in atmospheric carbon? Increases the rate at which carbon dioxide is released into the atmosphere. Carbon is a byproduct of the burning of fossil fuels and gets put into the environment, okay? Releases carbon monoxide and dioxide when burned, all right? We still maybe haven't hit to the root of it. I mean, I'm right now breathing out carbon dioxide. So, but I'm not increasing, I'm not contributing to a net increase in atmospheric carbon. What's the difference? Why are carbon, or why is burning of fossil fuels contributing, but, you know, our cell respiration is not? And it really goes back to the origin of fossil fuels. Much larger, much faster rate. Yeah, Sally, it's old carbon. So when we're burning fossil fuels, we're releasing carbon that has been sequestered. What does that word sequestered mean? We're releasing carbon that's been sequestered underground for millions of years and adding that. What is the definition of sequestered? Not necessarily alone, more like stored. So sequestered just means stored. So we're releasing carbon that has been stored for millions of years underground. And so it's interrupting the natural carbon cycle. So how does carbon cycle between atmosphere and biosphere? Something is taking it in, something is releasing it. I've already given you the part about releasing, but what takes in carbon? Photosynthesis, yeah. Trees, photosynthesis by trees, awesome. I love the hive mind. So plants are taking it in, good. Animals are releasing it. And when we take this other source of carbon and add that into the atmosphere, we disrupt that process. And that's why we have a net increase in carbon dioxide in the atmosphere. How does all of that relate to biofuels? So how does this relate to biofuels and why biofuels might be a better fuel alternative than petroleum? And maybe this goes back to, do we know what biofuels are? Because we certainly have to know the definition of biofuels before we can answer this kind of a question. Any ideas? All right, biofuels might be from microalgae. We're going to make ethanol, or we can make ethanol from switchgrass. We can make ethanol from corn. That's probably the most common way we make it in the United States. And so why don't those lead to a net increase of carbon? What's different about burning switchgrass or burning any kind of biomass, trees, and burning fossil fuels? Yeah, the carbon that's stored isn't old. It's not ancient carbon. You know, it may be, you know, a tree could be 100 years old. I mean, they could certainly be older than that, but you know, the grass, I mean, that turnover may be maybe months or years that we're releasing, you know, carbon that was out there just a few years ago. Okay, what would you like to work on next? It looks like we've got 100 and 200 in renewables, and then at least one in all the other categories. General for 200, and that'll finish that one. This fuel produces over 50% of the electricity in the United States. This fuel produces over 50% of the electricity in the United States. Very nice. Ty, coal, yep. All right. What category would you like next? Fossil fuels, nuclear, miscellaneous, or renewables? Miscellaneous for 200. Which of the following energy sources is not derived directly or indirectly from solar energy? And your options are geothermal, photovoltaic, hydroelectric, biomass, or wind. Which is not derived directly or indirectly from solar energy? Ooh, I'm seeing geothermal out there. Lots of times. Okay, the answer, which you guys several have come up with, is geothermal. Let me just explain for a moment about geothermal. So your earlier answers, you had photovoltaic. What's producing the energy in photovoltaic? The sun. So that is directly coming from the sun. What about biomass? Where does the energy in biomass come from? Plants, but ultimately where are plants getting it? Where are plants getting their energy from? From the sun. So both of those are directly from the sun. What about hydroelectric? How is that related to, either directly or indirectly related to the sun? And it's really about what drives the hydroelectric cycle. And we're thinking about all those words. Yeah, sun and evaporation, nice. So evaporation, which is caused by the sun, is driving the hydroelectric cycle, and that's why it's indirectly related to the sun. The other one is wind. Wind was on that list. How is wind related to the sun? Perfect. Uneven heating of the earth. So because we have more direct sunlight heating the equator, it is causing the earth to heat up, it's causing the air above it to heat up, and that warm air is rising. And that really is the start of wind, because we've got air coming in to replace it, and that's what's causing wind. So nicely done. All right, we're down to 3 optional categories. Renewables for 200. Mass productions of this alternative energy source could cause an increase in food prices. What mass production of what particular source could cause an increase in food prices? Biofuel. Yes, awesome. That is absolutely it. So I found this little diagram here about corn production, because most of our ethanol in the United States is being produced by corn. Anybody know in Brazil what most of the biofuel is, what source it's coming from? You may or may not know what their main ethanol crop is. It's not soy, it's actually sugarcane. Yeah. So, yep, Ty, the corn should be making you think about the omnivore's dilemma. All right, so this is just an interesting thought. You know, if we start using corn to produce a whole lot more ethanol than we do already, there's going to be an impact on food prices. Okay, 3 categories: fossil fuels, nuclear, renewables. What would you like? Renewable for 100. Name a type of power plant that is not thermal. So we've talked about a lot of different power plants today. Name one. There's actually 2 that I'm thinking of that is not thermal. Coal is going to be a thermal plant because we're burning coal in order to heat water to release steam. And so that makes it a thermal plant. Anything that where we have to burn wind would be a good one. Yep, a wind plant. Hydroelectric is another good one. Nuclear is also considered a thermal plant because you're harnessing the energy released from that nuclear reaction to create steam. And so that's another one. I didn't have wind up here, but hydroelectric is there. Solar, I put a picture of this because I think it's maybe the least, the one that we think about the least is producing electricity. But, and we do have a few of these in the United States, especially out west. You have these heliostats, which are just giant mirrors. They're going to direct sunlight at a central receiver. That receiver, it may be water. I think it's usually something with a lower boiling point that is creating steam. And then again, it's generating, a turbine generator sort of thing going on. It's not traditionally thought of as thermal, even though we do have the steam going on. But yes, that is absolutely true. There are some horrible little pictures of birds that have flown in the way of these sun rays and just been like vaporized. So I think when you're thinking about learning about each one of these topics, think about any of the fossil fuels or the renewables. One of the things that you want to know is, how does it work? You want to know, how does it, what are the advantages of that particular process? And then what are the disadvantages? So yeah, bird vaporization is definitely one for those solar power plants. Okay, fossil fuels or nuclear. I'll see fossil fuels first, so we'll do that one. This type of coal mining is safer for workers, but more harmful to the environment. This type of coal, oops, it should say of, not if. This type of coal mining is safer for workers, but more harmful to the environment. Surface mining, yes. What kind of surface mining is pictured here? Fortunately, one that's, pretty common in our state. Strip mining is a type. This is mountaintop removal. Yeah. So it's safer for miners because they're not at risk of a mine collapse or an explosion or a flood. All of those things have happened. But it's pretty devastating for the environment because we have to remove all that material at the top before we were able to mine. And you guys probably know some of those. Mountain type removal and strip mining are not really the same. There's mountain type is just one type of surface mining. So with strip mining, and I don't have a quick picture I can show you of that, you're mining in strips. Both are going to involve removing all the overburden or the material you don't want, like trees and soil and any other maybe rock that might be above that coal seam, and then accessing that coal directly from the surface, and then you're putting that material on top. So those are both two different things, but they do have definitely some similar impacts. All right, nuclear power for 200 it is. What waste products are produced by nuclear power? What waste products are produced by nuclear power? And we've talked about some that are not. Heat. I probably wouldn't consider heat a waste product per se, because we are having this reaction in order to harness heat to be able to get water into steam to run our boiler, or to run our turbine and our generator. Radiated products. Yeah, I mean, I'd probably say radioactive waste is going to be the biggest issue. So remember that nuclear doesn't release carbon dioxide. It doesn't release sulfur dioxide like we talked about. It doesn't release particulates, but it does, have this material, radioactive waste, that we have to do something with. The overall volume of radioactive waste is much less than a coal-fired power plant. In fact, the amount of mining that we need in order to get uranium-235 is less than the amount of mining we have to do to get coal. And so, I mean, there are some definite advantages, less mining, there's overall less waste produced, but we don't really have a good solution for what to do with our radioactive waste. Does anybody know what the site is where we had originally planned to put, we're going to send all our radioactive material to this one site in the United States? And if you actually just know what kind of, it was Yucca Mountain. in Nevada. So geologic burial has been our plan all along, but we've never been able to agree on whether or not we want to do that. And there's a lot of negatives with transporting waste across the United States. So where is all radioactive waste being stored if we don't have a central location? Where is all radioactive waste being stored? Did France, it's stored on site, yes. Did France figure out a way to recycle it? So France, it's good that you mentioned France. They rely heavily on nuclear power, probably more than any other country. In fact, countries that don't have some sort of resource in the ground, like coal or petroleum or natural gas, will rely on nuclear because it requires so much less. But I don't know, I mean, there's a breeder reactor that you can use where you can use some of that waste to continue to generate some power, to use it in a nuclear reactor called a breeder reactor. But I don't know that you're going to, totally use that. There's going to be some radioactive waste. And even the power plants themselves, when they're decommissioned, would be considered radioactive waste. All right, I'm going to see if I can venture back to 400, and that might mean my screen's going to be a little bit ugly for a minute because I'm going to have to go back to my original game and launch it again, and it's probably going to play music for us, which will be maybe fun, maybe obnoxious. All right, I'm going to go back to our board to fossil fuels for 400. That was not it.
The 500, I think.
500, okay.
There you go.
Here we go. This can be used at coal burning power plants to remove one of the major pollutants responsible for acid rain. This can be used at coal burning power plants to remove one of the major pollutants responsible for acid rain. So what's the device and what's the pollutant? Scrubber, excellent. What pollutant does the scrubber remove? I see scrubbers again, good. What is it removing? Sulfur dioxide. Here is the diagram of that process. So it's spraying a lime slurry on the gas that's coming out of the boiler where we're burning our coal. And it should be trapping that sulfur dioxide. There's a reaction with limestone that occurs. It does require that we have this disposal of the particulate that's formed. What's another major type of pollutant removal device at coal burning power plants? So wet scrubbers is one. What's another one? You can think about what's coming out of those power plants that we might have to remove. What's coming out of that smoke stream besides sulfur dioxide? Any ideas? Yes, particulates. What kind of device do we use to remove particulates? Filter would be a good, it's kind of a filter. It actually uses electricity. So it's called 5, 4, 3, 2, 1. Yeah, electrostatic precipitator. Nice. All right. That has been a little overview of nuclear and, well, renewables and non-renewables in general. Hopefully it was helpful for you. Thanks for everybody that attended. And thanks for participating. That was important.
And thank you so much, Debbie, Ms. Wheeler, and to you students out there. We look forward to seeing you. Good luck on the exam. You should be having a mock exam, and we're going to try to go over some of those questions with you at a date that's being determined, and hopefully you'll tune in and get some pointers for the AP exams. But good luck to all of you, and I hope you enjoy your afternoons. Thank you all for being here. Bye-bye now.
Bye, everybody.